Science Maths channel. I'm now answering question number 7 from the May-June 2024 paper 4 variant 2 mechanics M1 paper from Cambridge 9709. And this question here is about these inclined planes and is there friction? No. Smooth pulley. Okay, it's rough plate, so there's friction involved. And there's also, I think, work, energy, and power involved. So there's a few different things that we're going to be dealing with in this question. So let's get on with it. I have taken a copy of the question down there. But first, let's look at some of these things here. In fact, we'll do it from here. Okay, so two particles P and Q of masses 2.5 and 0.5 kilograms, respectively, are connected by a light inextensible string. So it's a light string and it's inextensible. Okay, so light inextensible string. So light meaning that we don't consider its mass and that all the particles attached to it will have the same acceleration as long as the string has tension in it, as long as it's taut. Okay, inextensible, sorry, light meanings, let me correct that. Light meaning it has no weight and the tension in it is the same throughout. Inextensible meaning it doesn't stretch and the acceleration of all the particles attached to it have the same magnitude. A smooth pulley means that the tension on either side of the pulley is the same because there's no friction in the pulley. Okay, so particle P is on the plane and Q hangs below the pulley such that the level of Q is 2 meters below P. P and Q, there's 2 meters vertical distance between them. Particle P is released from rest with the string taut and slides down the plane. The plane is rough, means you have to deal with friction here, and the coefficient of friction is 0.2 between the plane and P. So the coefficient of friction is normally given as the symbol mu. So the symbol mu is what stands for the coefficient of friction, so 0.2. Okay, so basically upon release, P is going to accelerate this way and Q is going to accelerate that way. So we want to find the acceleration of P. So the acceleration of P and Q is the same. Why? Because they're connected by a light inextensible string. So P and Q have the same acceleration. Okay, they have the same magnitude of acceleration. The same magnitude of acceleration. Okay, both the same. So the acceleration of A going up and the acceleration of P going down the plane is the same. So we can take Q and we can make a force diagram on Q. If we consider Q, it is going to have a force acting directly down, which is its weight. It's going to have a force acting vertically up, which is the tension in the string. And the tension in the string is the same throughout the string. So the tension acting on Q upwards is the same as the tension acting, so this is 0.5 G. Okay, and this is accelerating upwards. That's for Q. So we can resolve the forces for Q. As it's going upwards, we can say T minus 0.5 G is equal to the mass, which is 0.5 times acceleration, which we don't know. So this is the resultant force is equal to the mass times the acceleration. Okay, and for P we can do something similar, but for P we have to think a bit more carefully. For P we have to think a bit more carefully because you have your inclined plane and you have P. Okay, so for P we have a different situation slightly. I'll just draw this down there so that it doesn't get in the way of the forces. So this is for P. Okay, so you have the acceleration is this direction. The forces acting on P are, okay, I'll do this instead, are its weight, which acts vertically down, and also the reaction force between the plane and object, the reaction force always acts perpendicular to the plane that the object is in contact with. So this is the weight, which is 2.5 G. This is the reaction force, which we don't know. It's accelerating down the plane, as we just mentioned. And because there's a tension in the string, of course, that tension in the string is the same as this tension here. But you have an additional force, which is a frictional force acting, opposing the motion. Friction always opposes the motion. So the frictional force is also acting up the plane. So I'm going to draw it like this. And that frictional force has reached its maximum value. And we know F max, I'll put it here, F max is equal to mu r. So the frictional force can never exceed the maximum value for the particular situation that's in, which is dependent on the reaction force, and it's also dependent on the value of mu. Okay, so if something started to move, the maximum value of friction has been achieved. So we know for sure it's moving down the plane, F max is there. So those are the forces acting on the particle P. So we're going to resolve those forces parallel and perpendicular to the plane. So the only force that is not parallel and perpendicular to the plane is the weight. So I'm going to resolve this weight parallel and perpendicular to the plane. Okay, so that's what I'm going to do now. Just make that a bit thinner. Okay, so now we have the weight. I'm going to resolve the weight in a direction parallel and perpendicular. So let's start with perpendicular to the plane. So this is 2.5 G. Okay, now the angle that the plane is inclined to horizontal is 30 degrees. Okay, that's 30 degrees, which means this angle here is also 30 degrees. And the reason it's 30 degrees is because of similarity. Okay, because the line to move. Because similarity of these two triangles. This triangle here, it's supposed to be perpendicular anyway. Okay, this triangle here, there's a right angle there. Okay, this is 30, and you have this angle. And you have this small triangle, there's a right angle here. This angle is the same as in this triangle. That means that must also be the same as that angle. It must be 30. So by similarity, this angle is 30. So if I'm resolving the force in the direction which is parallel or perpendicular to the plane, I'm going to have to go into the angle to resolve it. So it's like I'm finding the adjacent side. So this is going to be 2.5 G times cosine 30. When you go into the angle, you use cosine. However, if you want to resolve the force, which is going perpendicular to the, or parallel to the plane, sorry, when you go parallel to the plane, in this direction here, parallel to the plane, then you have to go away from the angle 30 here. So when you go away from the angle, you are now having to use sine. Okay, so that's going to be sine. So down the plane here, we're going to use sine. So these red lines are the components of this weight in the direction that we want them to be in. So 2G times sine 30. So these are the components of this weight, parallel and perpendicular to the plane. Okay, so now we need to know what the value of F max is. Okay, F max is mu r. So we need to find what r is. So if I resolve perpendicular to the plane, we can see r is equal to 2.5 G times cosine of 30. So that's going to be 25 times root 3 over 2. Okay, so r is 25 root 3 over 2 newtons. And therefore F max, as we said, is 0.2 times that. So that's 1/5 times that. So we know that mu is equal to 0.2, which is the same as 1/5. So F is 1/5 times 25 root 3 over 2. That cancels that. So the F max is 5 root 3 over 2 newtons. So that's F max. So we can now resolve the forces in this direction, which is in the direction it's moving down the plane. So we have the resultant force is 2.5 G times sine 30 minus F max minus T, and that's equal to the mass, which is 2.5 times A. Mass times acceleration. That's the resultant force is equal to mass times acceleration. So this is going to be 25 times a half. 25 times a half, that's 25 over 2. Minus F max, which is 5 root 3 over 2. That's 5 times root 3 over 2. Minus T is equal to 2.5 A. So that's basically, that's 25 minus 5 root 3 over 2. You can say that becomes 25 minus 5 root 3 over 2 minus T equals 2A. So here we have one equation, and here we have a second equation, which we can then combine together. I don't have enough space now. Do I have space on the other page? I don't give much space here, but anyway, I'll sort it out here. I'll make some space. I didn't realize how. Okay, so I'll put this over here. All right. So if I take equation 1 and 2 and I add them together, if I take this equation, just to make it clear, I'm taking this equation and I add them together. Okay, if I add them together, equation 1 plus 2, what happens is the T is eliminated. Okay, so you're left with minus 0.5 G plus this. Okay, so you can say this is T minus 5 equals 0.5 A, because G is 10, so that becomes 5. So I'll just use this as my 1. Okay, so if I add these together, the T's are eliminated and we're left with basically this minus that. So you have 25 minus 5 root 3 over 2, and you're going to have minus 5 is equal to 2.5A. Hold on. There's a little mistake here. That is supposed to say 2.5A. So that's going to give you 3A. Sorry, I made a mistake there. I wrote 2. Instead of 2.5, I wrote 2. It's supposed to be 2.5. So when I add these together, 0.5A plus 2.5A gives you 3A. So A is going to be a third of all of this. So I've kept everything in exact form. And now I can work out the actual acceleration. So I have 1 over 3 times I have 25 minus 5 root 3 over 2 minus 5. And that gives me 1.0566, 1.0566, which is 1.06 meters per second squared. So there's the answer to part A. Just about fit it in there. All right. So a bit of work there to do to get it, but that was fine. All right. So now we're going to do part B. Question 7, part B. And here we're told to use an energy method to find the speed of the particles at the instant when they are at the same vertical height. Okay, so now we've got to use kinetic energy, potential energy, and work done against friction and these kind of things in order to solve this problem. Now, so the first thing we've got to do to sort out in our brain is when will they be at the same vertical height? Okay, so you see what's going to happen is they're going to reach a certain level where they're going to be at the same height. But a lot of students will think that's exactly going to be 2 meters, half of 2 meters. That would be true if Q and P were both moving vertically up and down. Like if Q was moving up and P was moving vertically down, yes, they would reach the same level exactly halfway between those. But P is moving at an angle. So when they get to the same vertical height, okay, then P would have moved through this distance here, for example. Let me make that a bit thicker. P would move through this distance here. And Q would move through the same distance. This would be that same distance because they're attached by the same rope. So if P moves this distance, Q will move that distance. And let me call this level O. Whoops. Get the pin back. So this is level O. I'm going to call this level O when they reach the same level. So what we want to do is we want to find out, okay, what that distance is. So I'm going to call this X, and this is also going to be X because it's the same distance. Okay, this moves this distance down, this moves the same distance up because they're attached by the same string. Now, what we have to consider here is this. I'm trying to find this distance in terms of X. So I can think of this right angle triangle over here. Okay, this is X. Now, if you remember, the plane is inclined at 30 degrees. So therefore, by the fact that we have, corresponding angle, this is also 30 degrees. So what we have is a triangle that looks like this. So I'll just draw it over here. We have a triangle that looks like this. Okay, so this is 30 degrees. This is X. Okay, this is a right angle. So I can find what this is. Let me call it Y. I can find what Y is in terms of X. I know that the sine of Y, because this is opposite, this is hypotenuse. The sine of Y is equal to, the sine of 30, not sine of Y, what am I doing? The sine of the angle 30, the sine of the angle 30 is equal to the opposite over the hypotenuse. So that means Y is equal to X times sine 30. And we know that sine 30 is a half. So Y is equal to a half X. So this distance here is a half X. Right? So we know that X plus a half X is equal to 2. X plus a half X is 2 meters. That's X, that's a half X, that's 2 meters. We can use ratios here, but we can do this. That's going to be 3 over 2. X is equal to 2 meters. So if I multiply by 2 and divide by 3, X is going to be 4 over 3 meters. Okay? So this distance here, between here and here, is 4 over 3 meters. And that means the remaining distance, which is between those two, the remaining distance here is going to be, what's left is going to be 2 minus 4 over 3, which is 1 over 3. 2 over 3, sorry. 2 over 3. 6 over 3 is 2, isn't it? That's going to be 6 over 3. So that will be 2/3. So this is 2/3 of a meter. This is 4/3 of a meter. That makes 2 meters altogether. So now we know exactly at the point where they'll be at the same vertical height. So it's not going to be halfway, from these. It would be if they were both vertical, but one is at an angle. So that distance is the same as this distance, and that causes this, difference between their heights. So now we're ready to answer the question. So we got to think about an energy method. So we got to think about, when we think about energy, we think about the kinetic energy at the start plus the potential energy at the start plus the work in is equal to the kinetic energy at the end plus the potential energy at the end plus the work out. So the kinetic energy at the start here is 0 because they're being released at rest. The potential energy at the start, well, if this is our 0 potential energy, so this is where potential energy equals 0, this one is above the level. So remember, potential energy is given by mgh. So you have the mass, which is 2.5 times g, which is 10, times the height, which is 2/3 meter. Plus, then we have this one is below. So this is going to have a negative height, you can say. So it's going to be, I'll write it like this, 0.5 times 10 times -4/3. Okay, because it's below the 0 level. So it's going to have a negative height, you could say, right? Displacement. Okay, and that's equal to the kinetic energy at the end, which is a half times the mass. Remember, kinetic energy is given by a half times m times v squared. So for P, it's going to be a half times 2.5 times v squared plus, you're going to have a half times 0.5 times v squared for Q, and then you're going to have plus the work out. Now the work out is basically any work done that prevents the motion. Work in is basically anything that's pulling the object along a slope or something like that. If it's causing a vertical movement against gravity only, that's taken care of within the potential energy. So here there's no work in, but there is work out because there's work done against friction. And work done against friction, work done is the force times the distance. So what force is acting against this motion? The force is friction. So that's 5 times root 3 over 2 times the distance x. The distance x is 4 over 3. So you have 5 times root 3 over 2 times 4 over 3. So this is the work out against friction. This is the kinetic energy, and there's no potential energy is 0 at this level. Why? Because they're both at the 0 level. When they reach this height, they're both at the 0 level. So this is going to be equal to 0 here. Right, so in this case, this will be 0. So now if we solve this equation, we should find what V is. So this is 25 times 2, which is 50. So that's 50 over 3. And this is going to be, that's 50 times, that's going to be 5 times 4. This is minus 20 over 3 is equal to a half times 2.5. That's 1.25 V squared. And that's a half times, so that's 1.25 plus 0.25. That's going to be 1.5 V squared. And here you're going to have this 2 cancelling with this 4. That's going to be 2. So you're going to have 10 root 3. So it's going to be plus 10 root 3 over 3. So we can now, this is going to be 30 over 3, which is 10, minus 10 root 3 over 3, equals 3 over 2 V squared. I've just written it as a fraction, so it's easier. So now we want to solve this, so we can multiply both sides by 2. So V squared equals 2 times, and all of this, and then divide both sides by 3. So if you multiply by 2 and divide by 3, you're left with V squared on its own. So it's 10 minus 10 times root 3 over 3. And when I calculate this, I should get my answer. So this is going to be V squared. Okay, so let's get the calculator in here. So you're going to have 2/3 times 10 minus 10 times root 3 over 3. Close the bracket. That's V squared. Okay, so V, I'll just write it like this to save me writing too much. So V is basically going to be the square root of all of this. So V is going to be equal to, so I'll just take this, I'll find the square root of the answer, and it gives me 1.6785, 1.6785. So to 3SF, that's 1.68 meters per second. And there's the answer for part C. And that concludes this question from the May, June 2024, paper 4 variant 2 for mechanics. Other questions from this paper can be found in the playlist that will appear in this section over here. Other questions from the topic of inclined planes and dynamics can be found in the playlist over here. And you can find questions about connected particles in this playlist, and work, energy, and power questions in this playlist over there. I hope that was clear. Thank you for watching, and see you soon.